This week, we're going to learn how to divide mixed numbers by fractions. Here we go. The first step is to change all the mixed numbers into improper fractions. 2 and 1/4 divided by 3/4 becomes 9/4 divided by 3/4. Let's take a look at how that happened. We look at our mixed number 2 and 1/4. How did it get to be 9/4? We simply multiplied 4 times 2 and got 8, plus 1 is 9, and carried that over to be our numerator. Our denominator of 4 simply stayed the same. Our division sign stayed the same, and our second term stayed the same. That's our first step. Let's move on to the second step. Our second step has several parts to it. However, you're familiar with some of these parts. The second step requires us to change it into a multiplication problem. It also requires us to change the second fraction into the reciprocal. As you already know, whenever you're working with fractions, you should cross cancel before you multiply, and your final answer must be a mixed number or just a regular fraction. Let's look at our problem again. 2 and 1/4 divided by 3/4 became 9/4 divided by 3/4. This part was our first step. Let's move on to our second step. 9/4 stayed 9/4. In our second step, our division sign became a multiplication sign. That's the first part. The second part of our second step is changing that second fraction into a reciprocal. Our 3/4 became 4/3. If you don't remember how to change a fraction into its reciprocal, please see previous lessons. It's simply turning it upside down. Now, as we looked, because we know that we should be canceling, we've got to look at our crosses. As we look at this first cross here, we notice that we have 2 4s. We notice that we can simplify those 2 4s. How many 4s fit into 4? 1. How many 4s fit into 4? 1. That's how we got the denominator of our first term and the numerator of our second term. As we look at this side to cross cancel, we see a 3 and a 9. Those can certainly cross cancel. How many 3's fit into 3? 1. How many 3's fit into 9? 3. So our new problem that we're working on this side of the equal sign is 3 over 1 times 1 over 1. We notice there's definitely nothing to cross cancel again, and we simply multiply across. 3 times 1 equals 3, and 1 times 1 equals 1. We know that 3 over 1 is simply the whole number 3. Let's look at some of the common errors that students make when they're working with these types of problems. Let's look at our problem again. 2 and 1/4 divided by 3/4. 2 and 1/4 becomes 9/4. That looks good. Our division symbol became our division symbol, and 3/4 became 3/4. It looks like this student did the first step correctly. Let's look at the second step. 9/4 became 9/4. That looks okay. The division sign became a multiplication sign. That looks good. 3/4 stayed 3/4. Uh-oh. This student looks like they did not take the reciprocal of the second term. In addition, it looked like they multiplied incorrectly. 9 times 3 is not 18. Also, they look like they have an improper fraction that should have been turned into a mixed number. Remember, anytime you have an improper fraction for your final answer, it should be converted into a mixed number. Your final answer should always be a mixed number if you have an improper fraction. Let's take a look at the next one. Let's see what this student did. 2 and 1/4 divided by 3/4. 2 and 1/4 becomes 9/4. That looks okay. Divided by stayed divided by, and 3/4 stayed 3/4. That looked fine for our first step. Let's take a look at the second step of the problem. 9/4 became 4/9. What did this student do? It looked like this student took the reciprocal of the first term when they should have been taking it from the second term. So right away we know that that student did something wrong. They did change it into a multiplication symbol, but they didn't take the reciprocal of the second term. Additionally, they did multiplication incorrectly. We can also tell that even if those things were all correct, this would be an incorrect answer because even though it's not an improper fraction, it is a fraction that has even numbers. And we know that when we have an even numbered fraction with the numerator and denominator, we can always reduce. Let's take a look at our last example of what could go wrong. 2 1/4 divided by 3/4. 2 1/4 became 9/4. That looks good. The division sign is the division sign, and 3/4 is 3/4. It looks like our first step looks good. Let's move on to our second step. 9/4 became 9/4. Our division sign became our multiplication sign. That looks good. And 3/4 became 4/3. That part looked good. Let's see what happened with the rest of the problem. Well, it looks like they didn't cross cancel when they should have cross canceled. And let's look and see what they did. Because sometimes even if you don't cross cancel, you might get a bigger improper fraction that you can reduce. 9 times 4 is 36. 4 times 3 is not 6, so that answer was incorrect. Let's work on you try it. 1 2/3 divided by 2/5. Get a paper and pencil out or dry erase materials and pause your video, work the problem, and then we'll go over it in steps. All right, here's our original problem. 1 2/3 divided by 2/5. Let's see if we can do our first step. 1 2/3 became 5/3 because 3 times 1 is 3 plus 2 is 5. So 5 became our numerator. We carried over our 3 as our denominator. In the first step, we leave our division symbol the same, and then we also take our 2/5, which is our second term, and that also stays the same in our first step. We've completed the first step, and that first step looks good. Let's move on to the second step. 5/3 becomes 5/3. That looks good. Divided by becomes a multiplication sign in our second step, and 2/5 becomes 5/2 in our second step. We also need to go ahead and take a look and see if there's anything that we can cross cancel. Can we cross cancel the 3 and 5? No, we can't. How about the 2 and the 5? No, we can't. Nothing goes evenly for any of those. So we simply multiply across. 5 times 5 is 25, and 3 times 2 is 6. Our final answer would not be 25/6 because that's an improper fraction. We have to convert that into a mixed numeral by dividing 6 into 25. And we end up with 4 and 1/6. We could check that because 6 times 4 is 24, plus 1 more is 25, and our denominator is 6. Here's another you try it. Pause the video, work the problem, and we'll go over it in just a few moments. 3 2/6 divided by 1/5. We know in the first step we have to change all our mixed numbers into improper fractions. Let's see how we did. 6 times 3 is 18, plus 2 more gives us our numerator of 20. Our denominator of 6 carries over. In the first step, our division sign remains the same. And our second factor, because this is just a regular fraction, just stays the same as well. We've completed our first step. Let's look at the second step. 26 is 26. That stays the same. In the second step, the division sign becomes a multiplication sign. Also in the second step, the second fraction has to be taken as the reciprocal. So 1/5 becomes 5/1. We then look for anything to cross cancel, and we don't have anything that we can cross cancel. So we simply multiply across. 20 times 5 becomes 100, and 6 times 1 becomes 6. Our final answer is not 106 because it's an improper fraction. We have to divide 6 into 100 to get the correct answer, which is 16 and 4/6. As we look at 16 and 4/6, we can multiply 16 times 6 and then get 96 and add 4. So we know that that's 106. As we look at 4/6, we can tell that that is a fraction that needs to get reduced, so our final answer becomes 16 and 2/3. One more, you try it. Here we go. 1/6 divided by 2 3/8. Notice in this you try it, the 2 3/8 is in the second position. It doesn't matter because the first step simply says to change all mixed numbers into improper fractions. So in the first step, 1/6 stays 1/6. Our divided symbol stays a division symbol. And 2 3/8 becomes 19/8 because 8 times 2 is 16 plus 3 becomes 19 as our numerator. And our 8 stays the same. Our first step looks good. Let's move on to our second step. In our second step, our first fraction of 1/6 stays the same. In our second step, the division symbol becomes a multiplication symbol. And 19/8 becomes 8/19 because of the reciprocal. Let's look and see if there's any cross-canceling we can do. 1 and 19 can't be cross-canceled, so they stay the same. 6 and 8, because they're even numbers, have 2 in common, so they can cross-cancel. How many 2's fit into 6? 3. We put our 3 down. How many 2's fit into 8? 4. So we put our 4 down. We check again to see if there's anything we can cross cancel, and there's not. So we simply multiply across. 1 times 4 is 4, and 3 times 19, oops, is not 19. That needs to be something else. So 1 times 4 became 4, and 3 times 19 became 48. So 4/48, we know both the numerator and the denominator are ending in an even number, so we can reduce even further. We always go by 2, and now we get 2/24. We also see that these can be reduced. 2/24 are both even numbers, so they become 1/12. We also could have taken 4 and 4/48 and looked at 4 and just got straight to 1/12.